Good afternoon, all of you. Today we will discuss the Mathematical Economics Part 1. In that, firstly, we have to discuss the syllabus of that. What is the syllabus of the Mathematical Economics regarding the SAT and NET examination? SAT functions and continuity, sequence series, differential calculus and its applications, linear algebra, matrices, vector spaces, static optimization, their problems and applications, input-output model, linear programming, difference and differential equations with applications. So ज्यावेळी आपण मॅथमॅटिकल इकॉनॉमिक्सचा पार्ट बघतोय त्यावेळी आपल्याला त्यामध्ये सेट्स जे काही आहेत संच त्याच्या थेरीज आहेत त्या आपल्याला बघायच्यात किंवा मग विच टाइप ऑफ सेट्स आर देअर किंवा डिफरन्शियल कॅल्क्युलस असेल विकलस काय आहे त्याचे टाइप्स काय काय आहेत लिनियर अल्जेब्रा सारणी मॅट्रिक्स म्हणजे सारणी त्याचे टाइप्स कुठले कुठले आहेत त्याच्या रिलेटेड तुम्ही मागच्या काही क्वेश्चन पेपरचे अनालिसिस केल्यानंतर लक्षात आलं असेल की मॅट्रिक्स जे आहेत तर त्याची ऍडिशन असेल मल्टिप्लिकेशन असेल किंवा सबट्रॅक्शन असेल तर त्याचे मोस्टली चार पाच एक्झाम्पल्स आलेले आहेत. त्यानंतर डिफरन्स अँड डिफरन्शियल इक्वेशन्स जे आहेत तर डिफरन्शियल इक्वेशन्स किंवा रेषीय ज्याला प्रोग्राम म्हणतो आपण लिनियर प्रोग्रामिंग तर त्याचे सुद्धा एक्झाम्पल्स आपल्याला आलेले आहेत. सो introductory part, in that firstly we have discussed the set theory. Set, what is meant by the set and what are the importance of the set, what the function of the sets. सो जे काही सेट आहे ज्याला आपण संच म्हणतो तर संच म्हणजे काय नेमकं त्याचं फंक्शन्स काय काय आहेत किंवा ही थेरी जी आहे सेटची संचाची थेरी आपल्याला कुठे कुठे इम्पॉर्टंट आहे तर या गोष्टीचा थोडासा आपण विचार करूयात. Sets are used to define the concept of relations and functions. The study of geometry, sequences, probability म्हणजे भूमिती असेल किंवा मग संभाव्यता असेल तर त्याच्यासाठी आपल्याला सेटचं नॉलेज फार महत्वाचं आहे. सो द स्टडी ऑफ जॉमेट्री सिक्वेन्सेस प्रोबॅबिलिटी एक्सेट्रा requires the knowledge of sets. Studying the state helps us to categorize the information. We have to categorize the information into different parts. That is the main mission or main vision of set. It allows us to make the sense of the large amount of the information by breaking down into a smaller group. Means set can be divided into different parts. So what is the history of set? The theory of set was developed by the German mathematician George Cantor. The tenure of George Cantor is 1845 to 1918. A single paper, however, founded a set theory in 1874 by George Cantor. What is the name of that particular single paper or single theory? On a characteristics property of all real algebraic numbers. Just for the information purpose, we have to discuss the history of set. It is not asked in the exam, but we have to discuss that. He first encountered the set while working on the problems of the trigonometric series. What is meant by the trigonometry? ज्याला आपण त्रिकोणमिती म्हणतो. फॉर एक्झाम्पल साइन कॉस थीटा जे आहे तर त्याला आपण ट्रिग्नोमेट्री म्हणतो. So the Cantor published the 6-part treatise on set theory from the year 1879 to 1884. This work appears in Mathematician Annalen, and it was a brave move by the editor to publish the work despite the growing opposition to Cantor's idea. The next wave of the excitement in the set theory came around 19 when it was discovered that Cantorian theory, set theory gave the rise to the several contractions. We know that the Bernard Russell and the Ernest Zermelo independently found the simplest and the best known paradox, now called the Russell's paradox. Paradox म्हणजे रसेलचा विरोधाभास म्हणतो आपण त्याला. Consider the set of all set that are not the member of themselves. It means set of all set are not the members of themselves. This is the paradox of Russell. The ultimate paradox was found by the Russell in 1902 and found independently by Zermelo. It's simply defined as a set A is equal to curly bracket X or X is not a member of X. Russell used his paradox as a theme in his 1903 review of the continental mathematics, his principle of mathematics. Zermelo in 1908 was the first to attain the axiomatization of the theory. Gödel showed in 1940 that the axiom of the choice cannot be disproved is using the other. So this is the some history of the particular set theory. We know only the George Cantor who developed first, who is the German mathematician and who developed the theory of set. And then Russell's paradox. What is the Russell's paradox say? The set of all set that are not the member of themselves. Just it. So set theory does have its places in business organization, any organization. What is the importance of theory? In that the set theory does have its place in a business organization. Any organization essentially comprises of various type of resources such as man, machine, money, material, etc. To equate a set one of kind with a set of another kind, and impact on overall productivity of the organization through skilled worker within the set of all worker. Subset of the products, material, etc., which when inquire into analytically could pave of the way effective decision making and sound organizational plans, policies and procedures. इट मीन्स ज्यावेळी आपण सेट थेरी म्हणतो तर सेट थेरी ही फक्त आपल्याला मॅथमध्ये इम्पॉर्टंट आहे असं नाहीये, तर सेट थेरी ही बिझनेसच्या दृष्टीने सुद्धा महत्वाची आहे. म्हणजे जर आपण जे काही रिसोर्सेस आहेत त्यांचा विचार केला, मशिनरी असतील, स्किल्ड लेबर असतील किंवा मटेरियल असेल, पैसा असेल, तर यांना सुद्धा आपल्याला एका डिफरंट सेट्स मध्ये आपल्याला सबसेट मध्ये इन्व्हॉल्व करता येतं. सो दिस इज द इम्पॉर्टंट. सो डिनोटिंग अ सेट ॲज अन ऑब्जेक्ट. वेन वी denote the set, which symbol are very important for the set purpose, that are follows. So where it is desirable to refer a set as an indivisible entity, one typically denotes it by a single capital letter. By convention, particular symbols are reserved for the most important set of numbers. म्हणजे ज्यावेळी आपण सेट म्हणतो तर त्या प्रत्येक सेटसाठी काही ना काही आपल्याला एक काय सिम्बॉल असतो. तर तो सिम्बॉल कुठला आहे ते पहिल्यांदा आपण पाहूयात. just 0 and slash is the empty set, that is called the null set. म्हणजे ज्यावेळी 0 आणि त्याला स्लॅश मारलेला असतो तर तो सिम्बॉल एम्प्टी सेटचा असतो. C फॉर कॉम्प्लेक्स नंबर, N फॉर नॅचरल नंबर, Q फॉर रॅशनल नंबर्स, R for real numbers, and Z for integers. So these are some symbols, very important symbols for the set theory. Empty set 0 and slash, C for complex number, N for natural number, Q for rational numbers, R for real numbers, and Z for integers. So theory of sets, term definition with the example set. What is meant by the set? What is the definition of set? What are the example of set? We can see here. A set is a collection of well-defined and well-distinguished object. It is well-defined and well-distinguished object. From a set, it is possible to identify whether a given object or element belong to a set or not. म्हणजे जे सेट आहे तर त्याच्यामधून आपल्याला हे आयडेंटिफाय करणं सोपं जातं की हा जो पर्टिक्युलर ऑब्जेक्ट आहे किंवा हा जो पर्टिक्युलर एलिमेंट आहे तर तो सेट संचामध्ये येतो किंवा नाही. फॉर एक्झाम्पल A इज इक्वल टू कर्ली ब्रॅकेट 2, 3, 4 bracket close. A is equal to all even integers, etc. For example, all even integers, elements of the set, the objects that make up the set are called the elements of the set. What is meant by the elements of the set? Elements of the set, object that make us the set are called the elements of set. एलिमेंट म्हणजे त्या सेटच्या अंडर जे काही घटक येतात त्याला आपण एलिमेंट्स ऑफ सेट म्हणतो. इट इज ऑल्सो नोन ॲज द मेंबर्स ऑफ द सेट ऑर बिलॉंग्स टू अ सेट. म्हणजे त्याच्यातील जे काही नंबर्स असतील, एलिमेंट्स असतील ते एक तर त्या सेटशी बिलॉंग करतात किंवा ते त्या सेटचे मेंबर आहेत. तर अशा पद्धतीचं आपण त्याचा डिफरन्शिएट करू शकतो. सो फॉर एक्झाम्पल A curly bracket 2, 3, 4. Here the 2, 3, 4 are the elements of the set A. Okay, in other words, 2A. So this is all the 2, 3, and 4 are the elements of the set A. Now the types of sets, term definition with example. Finite set. What is meant by the finite set? When the element of the set can be counted by the finite or the specific number of element, that set is called the finite set. What is meant by the finite set? The element of the set can be counted by the finite or the specific number of the element, then that is called the finite set. Symbolized as, for example, A is equal to curly bracket 2, 5, 8 bracket close. That is the example of the finite set. Another one is the infinite set. When the total number of element of a set cannot be counted, that is called the infinite set. Infinite म्हणजे जे काही जेवढे नंबर आहेत तेवढे जर आपण काउंट करू शकत असलो तर त्याला फायनाईट सेट म्हणतात. पण दिलेले जे काही सेट मधले नंबर आहेत ते आपल्याला इन्फिनिटी असतात, कितीही असतात, जे आपण काउंट करू शकत नाही त्याला आपण इन्फिनाइट सेट म्हणतो. दॅट इज इन्फिनाइट सेट इज सिम्बॉलाइज्ड ॲज दॅट infinity symbol. So for example, A is equal to curly bracket 1, 2 and more than 2, whatever. So that is the infinite set. So next type is singleton set. It is called the unit set. What is meant by the singleton set or unit set? It containing only one element is called a singleton set. Only one element in the set. म्हणजे एखाद्या सेट मध्ये फक्त एकच एलिमेंट असेल तर त्याला आपण सिंगल सेट किंवा युनिट सेट म्हणतो. फॉर एक्झाम्पल ए इज इक्वल टू कर्ली ब्रॅकेट 5. फक्त एकच आहे त्याच्यामुळे त्याला आपण म्हणतो सिंगल सेट, युनिट सेट or singleton set. Next point is, or next type is empty set, also known as null set. आपण जो म्हणजे 0 आणि त्याला जो स्लॅश मारलेला आहे तर तो सेम सिम्बॉल जो आहे तो आहे एम्प्टी सेटचा. सो एम्प्टी सेट also known as null set, void set. A set having no element is called the empty set. The symbol used the empty set is the Greek letter for the empty set. So, for example, A is equal to curly bracket empty set. It shows the empty set. Another one is the equal set. What is meant by the equal set? Two sets A and B are said to be equal whenever every element of A is also an element of B, vice versa. इक्वल सेट केव्हा म्हणतो आपण? आता दोन सेट आहेत, सेट ए आणि सेट बी. आता सेट ए मध्ये आणि सेट बी मध्ये जे काही एलिमेंट्स आहेत, घटक आहेत, ते सेम असतील तर त्या घटकांना आपण काय म्हणतो? त्याला म्हणतो आपण इक्वल सेट. सो देन it become an equal set. In other words, two set having some elements are called the equal sets. Same elements. The two sets which having a same elements, that is the equal set. It is also known as axiom of extension or axiom of identity. Symbol E is equal to B. A is equal to B. It means A set is equal to B set. That is the equal set. If, for example, if A is equal to bracket 2, 3 and B is equal to 3, 2 means both the sets have same symbols or same elements. That is the equal set. Another one is the equivalent set. What is meant by the equivalent set? If the total number of the element of one set are equal to total number of element another set, then the two element or two sets आर इक्विव्हॅलंट. म्हणजे एका सेट मध्ये जेवढे काही नंबर्स आहेत तेवढेच दुसऱ्या पण सेट मध्ये असतील, ते वेगळे असू शकतात, तर त्याला आपण म्हणतो इक्विव्हॅलंट सेट. द टोटल नंबर ऑफ एलिमेंट मे बी इक्वल बट आर एलिमेंट ऑफ टू सेट मे नॉट बी सेम. म्हणजे तीन असू शकतात. ए सेट मध्ये 3 सिम्बॉल आहेत किंवा 3 एलिमेंट आहेत, बी सेट मध्ये 3 एलिमेंट आहेत, पण ते सेम नसतील तर आपण त्याला इक्विव्हॅलंट सेट असं म्हणतो. इन अदर वर्ड, टू सेट्स हॅव्हिंग सेम नंबर्स ऑफ डिस्टिंक्ट एलिमेंट आर कॉल्ड द इक्विव्हॅलंट सेट. फॉर एक्झाम्पल, इफ A is equal to bracket A, B, C and B is equal to 1, 2, 3, these two are having a equivalent set. Another one is the subset, ज्याला आपण उपसंच म्हणतो. What is meant by the subset? Set of set, that is subset. If every element of a set A is also an element of set B, every element of set A is also an element of set B, then A is called the subset of B. And B is called the superset of A. For example, A is equal to 2, 3 and B is equal to bracket 1, 2, 3, 4. Then in B, and AB are the subset. A is the subset and B is superset. Another one is the proper subset. Proper subset if all the elements of a set A are also the element of subset B, but at least one element of a set B is not an element of a set A, then A is called the proper subset of B. For example, A is equal to 1, 2, 5 and B is equal to 1, 2, 4, 5. And B is the super proper subset of A because A does not have number 4. This is the example of particular subset, proper subset. Then power set. The family of all subset of set is called the power set. The family of all subset of a set is called the power set. Of that set is denoted as P of S. P of S is the power set. For example, if A is equal to 1 and 2, then P of S is equal to bracket null set 1, 2, comma 1, 2, in bracket 1, 2, close. So this is the example of the power set. Universal set containing all the elements is called the universal set. The set which containing all the elements. In other words, if all the sets are considered as subset of a fixed set, then that fixed set is called the universal set. This set is usually denoted as U. If A is equal to 1, 2, B is equal to 4, then U is equal to, U means universal set. Universal set is equal to 1, 2, 4. So the compound or element of A and B is equal to your universal set. Then Venn diagram pictorial presentation of a state theory is called the Venn diagram. Venn diagram also a part of a particular set theory. So generally we know that Venn diagram. And now we have to discuss the intersection of set. Intersection. What is meant by the intersection? The intersection of two sets A and B is the set consisting of all elements that belongs to both A and B. The intersection of A and B is denoted as A intersection B. This is the symbol of म्हणजे उलटा U जो असतो तो symbol आहे intersectionचा. So the A and B is denoted as A intersection B. For example, if A is equal to 2, 5, 7 and B is equal to 4, 5, 8, then A intersection B is equal to 5. म्हणजे हे जे दोन सेट आहेत A आणि B याच्यामध्ये 5 हा कॉमन आहे. मग तो कॉमन म्हणजेच इंटरसेक्ट करतो. म्हणून A intersect B is equal to 5. The properties A intersection B is the subset of both A and B. For example, A intersection B, A slash B, intersection of any set with an empty set is the null set. So we know that null set, that is empty set. For example, A intersection is equal to intersection of any set with itself is the set itself. For example, A intersection A is equal to A. म्हणजे जर समजा नल सेट असेल तर फक्त A इंटरसेक्शन A इंटरसेक्शन असेल आणि जर A इंटरसेक्शन A म्हणजे त्याच सेटने त्यालाच इंटरसेक्शन केलेलं असेल तर तोच सेट म्हणजे A हे त्याचं आन्सर येतं. इट हॅज अ प्रॉपर्टी टू commutative property. For example, A intersection B is equal to B intersection E. Intersection has the associative property. What is the property? Associated property, commutative property. A intersection bracket B intersection C is equal to A intersection B bracket intersection C. This is the associative property. If A is a subset of B, then B intersection A is equal to A, and if B is the subset of A, then A intersection B equal B. If A intersection A is a subset of B and B is the subset of C, then A is the subset of B intersection C. म्हणजे अशा पद्धतीचं जे काही इंटरसेक्शन आहे ए इंटरसेक्शन बी ब्रॅकेट तो जो सिम्बॉलाइज केलेला आहे तर त्याचं आपण डिस्क्रिप्शन देऊ शकतो. देन युनियन ऑफ सेट. व्हॉट इज द युनियन ऑफ सेट? द युनियन ऑफ टू सेट्स A and B is the set consisting of all the element that belongs to either A or B or both. The union of two sets A and B is called the logical sum of A and B, or A cup B, or A union B. Union is also known as join or logical sum of A and B. The symbol union denote for U. For example, A is equal to curly bracket 2, 3 and B is equal to 1, 4. Then A union B is 1, 2, 3, 4. So both the A element and B element are come under the logical sum A union B. The properties. The individual set composing a union are the members or the subset of that union of the set with itself is the set itself. For example, A union A is equal to A union of a set. With an empty set, it is a set itself. For example, AU, U is union is equal to A. It has a commutative property. For example, A union B is equal to B union A. Has an associate property. For example, A union in bracket B union C is equal to A union B bracket close union CB is the subset of A. Then A union B equals A, and A is a subset of B. And then A union B equals to BA union B is equal to null if A is equal to null and B is equal to null. So the not zero is considered null or empty set. Next is the distribution of law of union and intersection. A union B intersection C is equal to A union B intersection A union C. This is the distribution of law, union and intersection. So next is A union in bracket B, A intersect in bracket B union C is equal to A intersect B union and another bracket A intersect C. So we know that U is considered as the universal set. A is subset of U, then the complement of the set A is set UA and is denoted as A. So the set have many examples of that. The complement of a union is the intersection of the complement The complement of an intersection is the union of complement different of two sets. The difference of two sets A and B is the set of those elements which belongs to A and B, not B. So these are the subset of anything. The all those elements which belongs to B but not A is symbolically expressed as B minus A. What is? All the elements which belongs to B but not belongs to A. That is A, B minus A. The properties A minus B A is the subset of A and B minus A is the subset of B bracket A minus B. A intersect B and B minus A are mutually disjoint. A minus in bracket A minus B is equal to A intersection B and B minus in bracket B minus A is equal to A intersection B in bracket A minus B intersection B is equal to null. This is the another property of the complement union. So some mathematical or some symbolical formulas to remember. आपल्याला यातील काही फॉर्म्युलेज जे आहेत तर ते रिमेंबर करण्यासाठी महत्वाचे आहेत किंवा लक्षात ठेवावे लागतील. U इज इक्वल टू ऑर, ओनली, नायदर, नॉर, एनीवन, नॉट ऑल ऑफ दीज. म्हणजे युनिव्हर्सल जे आहे तर त्याला आपण ऑर म्हणू शकतो, ओनली, नायदर, नॉर, एनीवन, नॉट ऑफ ऑल दीज. इंटरसेक्शन, द मीनिंग ऑफ इंटरसेक्शन इज अँड, बोथ, बट, all, either or, only, one, first not, second or third. This type of symbol is used for all the features. So what are the formulas of the set? N of A is equal to N of A intersection B bracket close plus N of A intersection B. That is N of A. The N of A intersection B is equal to N of A minus N in bracket A intersection B. N of A universal B, U for universal, and जे काही उलट U आहे ते इंटरसेक्शन साठी. N of A universal B is equal to N of A plus N of B minus N in intersection B. N in bracket A universal B universal C is equal to N of A plus N of B plus N of C minus N of A intersection B minus N of A intersection C minus N of B intersection C plus N of A intersection B intersection C. Then N of A universal B universal C is equal to N of U minus N in bracket A universal B universal C. Then N of A is equal to N universal minus N of A. Then N of A intersection B intersection C dash is equal to N of A intersection B minus N of A intersection B intersection C. म्हणजे हे जे काही फॉर्म्युलेज आहेत तर ते तुम्हाला लर्न करावे लागतील, कारण याच्यावरून आपल्याला सेटचे जे काही थेअरीज आहेत किंवा सेटचे प्रॉब्लेम्स आपल्याला सॉल्व्ह करायला सोपं जाईल. सो सेट जे आहे तर सेटच्या पार्ट मध्ये आपण हे सगळं पाहिलेलं आहे की व्हॉट इज मीन बाय द सेट, व्हॉट इज द इम्पॉर्टन्स ऑफ सेट, विच सिम्बॉल are used for denoting the sets, then which type of the sets are here. So now we will discuss the differential calculus. त्याला आपण विकलज म्हणतो. डिफरन्शियल कॅल्क्युलस, इन दॅट व्हॉट इज द डेफिनेशन ऑफ कॅल्क्युलस, what are the classification of calculus, differentiation, derivative, differential curve, and formulas of differentiation. So firstly we have to describe or discuss the definition of calculus. The calculus is the branch of mathematics that deals with development, motion means the process or the power of changing place or position, maxima, greatest quantity, and minima, least quantity. मॅक्झिमा म्हणजे महत्तमीकरण, जी काही मोठी क्वांटिटी आहे त्याला आपण मॅक्झिमा म्हणतो, आणि मिनिमा म्हणजे न्यूनतम क्वांटिटी किंवा लिस्ट क्वांटिटी. This is one definition. Another one, the branch of mathematics that deal with finding the properties of derivatives and integral of the function by methods originally based on summation of infinitial differentiation or infinitesimal differences. So this one is the another concept of the calculus. Last one is the calculus is the particular method or system of calculation or reasoning. This is the particular method, particular calculation of reasoning. There are mainly two types of calculus. Which are they? First one is the differential calculus, and the second one is the integral calculus. So firstly we have to discuss the differential calculus, a branch of the mathematics concerned chiefly with the study of rate of change of a functions with respect to their variables, especially through use the derivative and differentials. First branch of mathematical analysis devised by the Isaac Newton and G.W. Leibniz. The first branch is discovered by the Newton and Leibniz and concerned with the problem of finding the rate of change of a function with respect to variable on which it depends. Thus, it involves the calculating derivatives and using them to solve the problems involving non-constant rate of change. It known use differential calculus 1702. म्हणजे पहिल्यांदा जे काही डिफरन्शियल कॅल्क्युलस आहे तर ते 1702 मध्ये सांगितलेलं आहे. याच्यामध्ये आपल्याला हा जो डिफरन्शियल कॅल्क्युलस आहे तो एक पार्ट आणि दुसरा इंटिग्रल पार्ट, तर हे दोन टाइप्स कॅल्क्युलसचे आपल्याला बघायचे आहेत. त्यामध्ये सेकंड वन आहे इंटिग्रल कॅल्क्युलस, अ ब्रांच ऑफ मॅथमॅटिक्स कन्सर्न विथ द थिअरी अँड ऍप्लिकेशन्स as in the determination of length, area, volume, and the solution of differential equations. Of integrals and integration, first known to use the integral calculus in 1748. The integral calculus branch of the calculus concerned with the theory of application integrals, while differential calculus focuses on the rate of change, such as the slope of tangent line and velocities. Integral calculus deals with the total size or the volume, such as the length, areas, and volumes. Differentiation. The process of finding the derivative is called the differentiation. To find the derivative this process is called the differentiation. The reverse process is called the anti-differentiation. Differentiation to finding the derivative and reverse process called the anti-differentiation. The fundamental theorem of the calculus states that the anti-differentiation is the same integration. Differentiation and integration constitute two fundamental operations in single variable calculus. So the differential calculus, what is meant by the derivative? Here we can see that this is the function of x, then the slope of the line which is tangent to the curve f of x is given by y divided by delta x, is the y divided by delta x. That slope is also given approximately by f of x2 minus f of x1 divided by x2 minus x1 is equal to delta f divided by delta x. So, where x2 and x1 is closer. If delta x were smaller, the exact slope can be found by the taking the limit as delta x raised to 0. So here the derivative gives the particular function changes is df in bracket df of x divided by dx lim x delta x to 0. So this is how the function of particular derivative is going on. So we can know how the function is doing a job. So df by dx, here the d is the rate of change, f means function, dx with respect to x is variable. It means d denominator d is with respect to variable x. Limit, lim for limit, h for change in variable to 0 means tend to 0. Here the f of h plus s is divided by h is changed into variable. Then here all the y-axis and the curve shows that how the differential calculus is shown on the particular y-axis and x-axis. So here the common function and derivative. Constant function c, derivative 0. If any constant symbol or constant number, then it is the number derivative is 0. Constant function c 0, then x, if the constant x is 1, square x square is 2x, square root x, the derivative is 1 by 2 x the power minus 1 by 2. Exponential e x or ax, e the power x is equal to function also derivative also e the power x. A the power x is equal to a the power x in bracket a. Logarithm in of x and 1 by x, then log a of x 1 by in bracket x in a. Then the trigonometry x is in the radians. Here the function is derived. Let y is equal to f of x is equal to c be a constant function. Then y dash is equal to f dash of o is equal to 0. So the derivative of the constant is, म्हणजे तुम्हाला क्वेश्चन विचारला जातो की डेरिव्हेटिव्ह ऑफ व्हॉट इज द फॉर्म्युला ऑफ डेरिव्हेटिव्ह ऑफ कॉन्स्टंट, देन यू हॅव टू राईट y dash is equal to f dash of x is equal to 0. This is the constant function of derivative. Differential derivative of exponential function. What is the derivative of exponential function? Let f of x is equal to e exponential, e the power x. Then by definition, f dash x is equal to limit h to 0, then f h plus h minus f of x divided by h. This is the hence the final equation we got that d by dx, x is here the variable, in bracket exponential is equal to exponential or exponential. So another one, the derivative of the sine function. If the sine function is there, and what is the derivative of sine function? D by dx sine of x. Same function, just you have to write the sine, and then we can got the cos of x. The sine of x, we got cos of x. The derivative of a is a power x means exponential is d by dx exponential is equal to a exponential into ln. So here the derivative of the natural logarithm or logarithm, that is d by dx ln x is equal to 1 by h. 1 by x. This is the derivative of exponential. And this curve show that how the natural logarithm function is. So in fact, finally we got d by dx ln x is equal to 1 by x. So what is the derivative function? When x is close to 0, then जेव्हा आपल्याला x हा खूप 0च्या जवळ असतो, त्यावेळी आपल्याला वर्गमूळ जो काही x आहे तो सुद्धा 0च्या जवळ असतो, then it is called the constant. So if function f dash x is equal to 1 by 2 root x is very large, and this is corresponds to a steep tangent line near 0, 0, 0, minus 0 or plus 0. म्हणजे x आणि y या दोन्ही वरही 0 आपण घेऊ शकतो सेंटर पॉइंटला. So differential calculate curve. If the question is here x the power 3, y is equal to x the power 3, then you have to describe y dash 1 is equal to 3 in bracket 1 the power square the power 2 is equal to 3. Then the slope of that particular tangent line is equal to 3. This is show that how the slope of the tangent line equal to 3. And the basic formulas of the differentiation is, जर तुम्हाला आपल्याला जर विकलज काढायचं असेल तर त्याच्यासाठी काही बेसिक फॉर्म्युलेज यायला हवेत. त्यामध्ये फर्स्ट आहे dk by dx is equal to 0. Here the k is your constant. dx by dx, d of x by dx is equal to 1. Then d in bracket kx divided by dx is equal to k. Here also the k is constant. And last one, d x the power n divided by x dx is equal to n of nx the power n minus 1. N is number. So here some problems and the how the derivative is derived. This is how derivative चे काही जे काही असेच्या असेच जो काही फॉर्म्युला वगैरे आहे तर तो विचारला जातो. So they use the definition of the derivative to find the derivative. F of x is equal to 0. Then the f of x plus h is equal to 3, since there is no x on the right. Then the derivative of the particular problem is f of x is equal to limit f of h x plus h dash f of x divided by h is equal to limit h to 0, 3 minus 3 divided by h, it means limit 0 is equal to 0. So this is the problem and derivative of the particular problem. So you can discuss and you can know what is the derivative, what is the problem of particular derivative. So आजच्या लेक्चर मध्ये आपण सेट थेरी आणि विकलज जे आहे तर त्याचे काय फंक्शन्स आहेत किंवा फॉर्म्युलेज आहेत ते पाहिलेलं आहे. सेट थेरी त्याचे टाइप्स काय काय आहेत तर ते विचारले जातात किंवा नल सेट वगैरे डिनोट कसा केला जातो तर असे काही क्वेश्चन्स तुम्हाला येतात. सो वी विल स्टॉप फॉर अ डे.